Welcome back. Today we're going to take this compounding interest a step further. We're going to talk about continuously compounding interest. Now, continuously compounding interest, so that means it is non-stop compounding. So that means you can't actually use a value for n because n would be infinite. So what that means is now we have a whole nother formula that we're going to use, which actually ends up being a little bit simpler to use than the true compounding interest equation. So we get this equation here. A equals PE to the RT. So P is still the amount that you handed the bank. R is going to be the interest rate, and T is time in years. And that E is a special number. Okay, it was calculated for this exact purpose. Now you may be thinking, Ms. Freshman, you're crazy. How is E a number? Well, you know how pi is 3.14. E is a number as well. E is about 2.71. All right? So E is a legitimate number. It's another one of those special numbers, a constant that was made for this purpose, just like pi was made for circles. So the key here is we're looking for when it says compounded continuously. That's how we know to use this formula. So suppose you won a contest at the start of the 5th grade that deposited $3,000 in an account that pays 5% annual interest, compounded continuously. How much would you have in the account when you enter high school 9 years later? And what about after you graduate 8 years later? So let's plug this into the formula. So we're starting with $3,000. E, well, 5%, don't forget, the 5% is 0.05 when you move your decimal over. So to E to the R, which is 0.05. Now when you enter high school, T is going to be 5. Okay? And again, I would type that into the calculator first. 0.05 times 4. 0.05 times 4, that's just going to be 0.2. So I would get a single decimal there, or a single value there for your exponent. And now you can use the calculator to calculate that. So let me show you. 3,000. E is above the division key. All right? So if you hit second and then the division key, that's where E is, to the 0.02 power. Oh, I'm sorry, not 0.02. It's supposed to be just 0.2. I apologize. And that gives you $3,664.21. $3,664.21. All right, now they also ask about 8 years when you go to graduate high school. So let's see how much money you have after 8 years. It's the same 0.05 rate, but this time times 8 for 8 years. Well, again, it's easiest to type into the calculator if you have a single exponent. So take 0.05, multiply that by 8, and you would get 0.4. So I'm going to use that in my calculation instead to make it a little bit easier. Okay? So 3,000 times E to the 0.4, you get $4,475.47. So you can see leaving it for 4 more years, you make quite a bit more money in this case. And you may notice this formula is pretty easy to use. Again, all you have to do is be able to plug in the right values, get a single number for your exponent, and then just to type into the calculator. One of the big ideas for this chapter, though, one of the big ideas is we have 4 situations we just encountered: growth, decay, compounding interest, and continuously compounding interest. So this table here, this is for your benefit. This kind of goes through some of the vocabulary that you can encounter to help you know which one to use. Which vocabulary indicates which type of problem. All right? So we're going to do 2 more examples because on the test, you're going to have to be able to pick out which equation to use. The equations will be given to you, but you have to know which one you can use. All right. So a culture of bacteria starts with 30 cells and grows at a rate of 16% every hour. How many bacteria will there be after 7 hours? Well, we're talking about growing, but we're not talking about any compounding interest. So this is going to be a simple growth model. So remember, our simple growth model just looks like that. So I start picking out the pieces that I need. Well, my A is going to be 30. I'm starting with 30 cells. A rate of 16%. Turn that into a decimal, which is going to be 0.16. And our T is going to be 7 hours. So our A is 30. 1 plus my rate of 0.16. Well, that's just going to be 1.16 to the T. So that's going to be my equation. But we know we're talking about 7 years. So I'm going to plug in that 7 in order to calculate this. So 30 times 1.16 to the, and we're talking about 7 years, or 7 hours, my bad. So we're talking about 85 cells approximately. Again, when you're talking about living things, round to the nearest whole number. We're talking about 85 bacteria cells. The Smith family is saving up for family vacation. They want to take in 5 years. They put $1,200 in the bank that has an interest rate of 8.8% compounded monthly. How much money will they have by the time they want to take their trip? All right. We're talking about compounding interest here. I can see the word compounding. So I'm going to identify my pieces. They're starting with $1,200. They have a rate of 8.8%, which again, if you convert to a decimal, it's going to be 0.088. We're talking about 5 years. They want to take their trip in 5 years. And finally, compounded monthly. Well, there are 12 months in a year. So that means my N is going to be 12. And that's what I'm going to use to plug into my formula. So I plug all of this in. R over N, then N, or N times T, or T times N, really doesn't matter. All right, again, the first thing I'm going to do is I'm going to take 5 times 12. And I'm just going to go and call that 60. just type that into your calculator first and get a single number there. It's easier later on if you just have a single number for your exponent. All right, so let's go and type that into our calculator. So we're talking about $1,200, 1 plus 0.088 divided by 12 to the 60th power. Type it into the calculator. So in 5 years, they're going to have $1,860.26. So that's how much money they're going to have in the bank for their trip. All right. Once again, thank you for joining me for this. Make sure you have all this written down, and then make sure you're asking if you have any questions in determining which equation that you need to be using.